Hi, welcome back. This is Sunny Ray, South Asia Channel Manager for Quanser. And in this presentation, again, we're going to repeat a little bit of some of the things we've repeated in the areas that we've presented in the previous videos. But essentially, the theme is the same, is engineering a better world. And we'll talk about how we enable educators, engage researchers, and empower industry. But this particular presentation will focus more on how Quanser has been working with National Instruments over the past many years. In fact, this year at NI Week in Texas, Quanser was awarded an incredibly prestigious award. We were awarded Best in Class Supplier. And that means a lot for the people at Quanser, all the way from our CEO to every single individual in the company. So this presentation will really be about general Quanser overview, and again, this will be a repeat of some of the other videos that I've done before, so if you're interested in a more in-depth overview, you can check out some of the other videos. So second part, we'll be talking about solutions for teaching and research, and third, last but not least, we'll be speaking about the Cube, which is very, very exciting. So to start the overview, again, as you know by now, Quanser helps enable educators. This is Dr. Jacob Abkarian, our founder and CTO, saying that my goal is to bridge the gap between theory and practice. And I believe Quanser over the last 23 years has achieved much of that, and there's still much more to achieve. But this is a really nice video of the mechatronics circle, and this is actually here Jacob speaking a little bit about
the next breakthrough in technology will likely be in robotics. We are physical beings, and sooner or later we'd like to manipulate our environment in more and more complex ways. As the systems that we are designing become more complex, mechatronics starts playing a very important role in the systems that we are designing. Mechatronics is a synergistic application of a variety of fields of engineering. These include control systems, mechanisms, electronics, software, computer architecture, and in order to get a fully functional system operating from the ground up, all these systems have to be designed together and in coordination with each other.
Well, you can check out the whole video on YouTube. That video is posted, but you heard it from Jacob. It's really, mechatronics is the intersection of computers, mechanical systems, electronic systems, and control systems. So it's everything. Enable educators. So we've been at this now for more than 2 decades, and there are over 2,500 universities engineering universities around the world that use Quanser solutions. So pretty much every top institution you can think of, whether it be Princeton or Stanford or IITs or MITs, most universities in the world are using something or another from Quanser, whether it be hardware or software or data acquisition cards or whatever. So over the years, we've had the opportunity to build over 100 different experiments such as DC motors, everything from robots to unmanned air vehicles and helicopters and earthquake shake tables, and I mean the list just goes on and on, with the common theme once again being real-time controls and mechatronics. So I've spoke about this again in previous videos, but I wanted to go over again that our systems are, or I'd say 90 to 95% of our systems are at this point, or will be very soon, in a very short period of time, will be fully compatible with LabVIEW. In fact, we even released a new software called RCP, which will make LabVIEW users who are working in the control space, it will make their lives considerably easier. And I wanted to just quickly show one page from our. If you come to our website and you click on workstation components and you go down to control software for NI LabVIEW users, you can actually get a lot of. Again, go to quanser.com and then workstation and then control software for NI LabVIEW, and you can get a lot of information. The specs are right there on the left-hand side. You can link to all our blog articles and YouTube videos. but a great resource to learn more about RCP. All of our experiments, especially the rotary family, the system that you see up on the top left there, it's compatible with ABET. So we actually work very hard to align our curriculum with the requirements of ABET, and that's a process that continues. Also, if you're using Norman Neese's controls textbook, which a huge percentage of professors are in the world today, you'll also find many visualizations and little exercises and references to Quanser experiments in that textbook. Now, the fourth component, once you have your plant, you have your software, you have your curriculum, and your teaching material, then you need data acquisition cards, or control boards, as we like to call them, and you need amplifiers. So whether it's a volt pack, or it's an amp pack, whether it's a 1-channel, 2-channel, or a 4-channel, you're going to need that hardware to drive your plant. So here you see the beauty of Quanser experiments is that you have a modular system, a modular base where our data acquisition cards and our amplifiers and our software. Once you have all of that set up in a lab, then really it's very simple to add new experiments, and thus reducing the need to, or eliminating the need to have to purchase all of this redundant material over and over and over again. You essentially equip your lab, such as this multidisciplinary lab here, with 15 workstations. And if you're teaching, let's say you have a mechanical engineering department today, when we visit universities, we oftentimes see PC, software, data acquisition cards, amplifiers, lab space, all in the ME department. And then you go to the civil engineering department, and you see the same type of things, and you see the same type of things in aerospace engineering, and the same type of things in electrical engineering. So our recommendation, or our suggestion, or what we've seen that's worked in the field is that universities that do have the vision and the foresight and the ability to really bring together all these labs into one space, they really do increase the value of the experience for the students and for the professors, and from a price point perspective, it reduces the cost of that one multidisciplinary lab considerably. So let's say, for example, you have a civil engineering professor who's wanting to teach, they want to simulate different types of earthquakes on building structures, and they need a shake table. So you can essentially roll up the shake table, connect it to your amplifier and data acquisition and to your computer, and you've got a civil engineering lab. Now let's say the rotary inverted pendulum system is being used for an electrical engineering lab. Well, you don't need to purchase all the base equipment over and over again. You essentially have this common platform. Same thing for mechanical engineering, whether it be for a linear inverted pendulum system, or for an aerospace engineering lab where they need 2 or 3 degree of freedom helicopter. Really, you get the point here, which is that the possibilities are really limitless, and by not having to purchase the hardware and the software over and over again, you do save a lot of money in the long run. So what do you see in the top left there? You see essentially what I felt like when I was in engineering, just overwhelmed, and when you look at the top right here, you see what's going on is that there's a budget crunch right now all over the world. There's a budget crunch, and how do you, in spite of wanting to save money, how do you give, or first of all, effectively use your space, and then more importantly, how do you bring new technology and more workstations to your students? And that's the whole goal. Is Quanser's in the business of captivating, motivating, and graduating quality engineering students, and really we believe that a lot more students would be engaged and probably still in engineering if there was some sort of exposure to hands-on equipment earlier on in their career. So the next part of the presentation, this is still part of the overview before we move into the actual details of any products, is we also work really hard at engaging researchers. And so here's an example of how we work with Dr. Venkat Krovi to bring one of his visions to life, which is a 6 degree of freedom hexapod. I wonder if I can share this video with you here. Yes, I can. So this is the 6 degree of freedom hexapod. In fact, the story behind this, I believe, is that they were actually looking to replicate a saber-toothed tiger's jaws, using a mechatronic system. And it was for some sort of industry application. And you see here that they've integrated the 6 degree of freedom hexapod, which is again now a product of Quanser's. Obviously, it looks a lot prettier than this. This is all opened up, and you see the inside of it. But there's a force-torque sensor on the top of this hexapod, and it's actually integrated with this haptic device, which we'll be talking about later on in the presentation. But on the top left there, you see. So again, this system is a very, very complicated, 6 degrees of freedom, heavy payload. I mean, it's you got 6 electric motors on there, and you've got computers and data acquisition cards, and this is not an easy project, but it was something that was feasible again because of Quanser's core expertise in mechatronics and control systems. So again, as we do work on specific research projects, our goal is always to turn around and offer these solutions as some sort of product for other universities to use, as you saw there with the Hexapod, the 6 degree of freedom platform, the Denso robot, which is again a wonderful platform for doing research. So you can ask us more about these systems here as well. I'm not going to spend too much time on this because there is quite a bit I want to share. So here, engage researchers. So again, there's, as you see here, we've done work in medical robotics, needle insertion, surgical robotics, rehabilitation, endonasal, and I haven't even talked about the SEAL project, which is just crazy. So maybe in a later video we'll talk about that. We offer unmanned vehicle systems as well. Again, if you're doing research in that area, do contact us. So the 21st century will be known as the age of automatic control. I love that quote. That's one of my favorite quotes. And National Instruments is really at the forefront of this movement, and Quanser is very, very happy and proud to be partnering with a company like NI to really be able to bring cutting edge technology into the engineering lab. So again, I want to just keep going here, and I want to talk a little bit about the solutions for teaching and research. So the first system I wanted to talk about is actually, well, we have the QET, but more than the QET, actually, I wanted to share, many of you may already be familiar with our QNet line of products. So QNet DC motor, sorry, I got a little excited there. The QNet DC motor control trainer, the QNet rotary inverted pendulum trainer, there's the QNet heat ventilation and control trainer, and there's the QNet vertical takeoff and landing trainer. There's the QNet mechatronic sensor trainer, which is just awesome. There's also the QNet myoelectrics board. So, these are 6 introductory platforms for controls purposes. I mean, I guess you could use this one for introducing biomedical. But most of these systems are designed for a controls lab. And these are what we call at Quanser Tier 1 products. So there's a really nice video online, actually, on the NI website, that if you go to this page that I'm showing here, you can actually check out this video. And again, I'm not going to play the whole thing, but I wanted to just share a few seconds of it.
Add-on modules include Elvis plans created by partners such as Quanser for controls and mechatronics, Imona for telecommunications, embedded design made by Freescale, and digital electronics boards made by Xilinx. These extensions to NI Elvis and the ease of use of LabVIEW software makes Elvis an ideal multidisciplinary engineering platform. Use the NI Elvis to teach controls and engineering concepts, including circuit design, measurements and instrumentation, telecommunications, and more, not only for different courses, but for different departments, such as electrical, computer, biomedical, mechanical, aerospace engineering, and physics. NI Elvis is the perfect platform to teach control design concepts by taking advantage of the different plug-in boards created by Quanser, a leader in control design training systems for academia. Quanser offers 5 plug-in boards for NI Elvis: the QNet DC motor, the QNet HVAC system, the QNet inverter pendulum. Now, 2 additional boards have just been created by Quanser. This includes the Vertical Takeoff and Landing, or VTOL 1 degree of freedom helicopter plant, and the Mechatronic Sensors 1 board. These boards also include VIs and curriculum that the educators can now use to teach the basics of control design.
Awesome. So once again, you can check out more about the QNets on NI's website. Again, I highly encourage you to do that. So moving on, I wanted to talk about our most popular line of experiments, which is actually the rotary family. This is my favorite system of Quansers, and let's see if we can, instead of just talking here, let me see if I can share some video. So the SRVO2 is modular, like I said. Not only is it modular in terms of you can use different experiments like laser beam and helicopters, the systems themselves are modular. So they're really like Lego for adults. So here you see the user putting on the flexible link experiment. So this represents a robotic arm in space that's flexible. And so how do you design a controller to minimize the oscillation in a flexible link, right? Well, you mount it on top of the SRVO2, you start the experiment up, and in a few seconds you've got a very novel lab. Now, let's say you want to do a double inverted pendulum. No problem. Just snap on the module and you're off to the races. So this modular aspect of the SRVO2 is really what has made it so popular. Again, you've got the rotary inverted pendulum here. This is probably the most popular experiment. So there you go. Again, this video, I apologize, it's a little bit older, but as you see there's a potentiometer here, so we use digital encoders on there, and the system itself may look a little bit different, but 99% of it's the same. So you see a nice little video there of that. I wanted to, again, I'd like to show more videos, but I'm going to just jump to my favorite one, which is the ball and plate. So here you've got 2 servos. So now you can take 2 of your servos. By the way, you can teach position and control, speed control. And again, I'll be doing more videos on this later, but you can teach many basic things with the servo itself, but then it acts as a part of this larger module. So you see 2 servos, one in the back, one in the front, and they're connected to this new module, which is a plate, and you've got a camera on top. And the idea is for the student to design a control system to balance that ball on top of the plate. Now, once they balance it, whether they want to create a pattern with it, like a square or a circle, it doesn't matter. But the idea is how do you use vision control to drive the mechatronic system? So I'm going to keep moving on here. Again, Quanser has invested a lot of time and energy into our hardware peripherals, and this is, so again, please do ask us about getting more information on this. We have a whole range of hardware and software designed from introductory all the way up to research. So again, there will be more videos on this stuff later if there's interest. The virtual labs is another important part of our labs. And as I mentioned before, we offer curriculum, which is very, very important. So again, I wanted to just quickly go through some of these here. Again, not in any detail, but we have 5 systems: the 6 degree freedom hexapod, the 3D gyro, 2DOF planar robot, industrial mechatronics drive unit, and the active suspension system, which are all great hands-on application-oriented systems that really get your students excited, but it allows you to actually implement all this theory that we learn on a real system. Now I wanted to just finish off the video here with talking a little bit about the Cube rotary servo system. So this is a system that is just being released in South Asia, mainly in India to start with. And here is a picture of the actual SRVO2 system, for the Cube system. It's similar to the SRVO2, but it's smaller, it's more compact, it's lower cost. And as you see, it's modular, but it's not, it actually uses a magnet. It's a beautiful system. It's going to be integrated with NI LabVIEW. And I'm just going to finish off today's presentation by running a video of the Cube workshop that we performed last month. So I'll finish off with this slide here. So you see there's PC and software, you have your data acquisition card, you have your amplifiers, you have your servos, you have your modules, and we talked about this whole thing. You got the ABET curriculum. Well, all that stuff you saw in the middle is pretty much integrated into the Cube. How cool is that? So, and then you've got a range of modules as well that you'll want to check out. So again, ask us more about, email us at info@quanser.com and we can get you more information about this. So once again, if you would like to see the video, you can check it out on YouTube, but I'll just play a few seconds of it here.
Show you what graphical system design can mean. So this is a concept of graphical system design. So before I start to explain graphical system design, let's know what is system design. So what do you think is
the position of the motor. So whenever the motor tap turns, it turns to the encoder. So the encoder continues to count. One way positive, the other way negative. Wonderful rotation gives you 2048 counts. So what you see the expression over here is basically